Welcome back. So, for literally decades, scientists viewed the immune system through a very specific, kind of limited lens. But then, the discovery of just one single molecule completely rewrote the rulebook of modern immunology and rheumatology. Today, we're jumping right into this explainer on interleukin 17, or IL-17, and looking at exactly how it completely shattered the old frameworks of human biology. Rheumatologist Dr. Vishwa Prakash Tiwari actually hit the nail on the head when he said, modern immunology is no longer just Th1 versus Th2. The IL-23/IL-17 axis has become the central paradigm of barrier-driven inflammatory disease. Okay, let's dive into this, because for the longest time, that whole Th1 versus Th2 model, that was the absolute gold standard for understanding how our immune cells respond to threats. But this quote highlights a massive, super exciting paradigm shift in science. We've officially moved into an era where an entirely new biological axis is taking center stage. But to really grasp this shift, we first have to understand what IL-17's primary function actually is. Basically, it's a powerful pro-inflammatory cytokine that's absolutely central to barrier immunity, neutrophilic inflammation, and autoimmune disease. I want you to think of IL-17 as the elite border guard of the human body. It stands right at the very edges of our mucosal barriers, acting as this vital security force that's just constantly scanning for breaches, ready to call in the cavalry the second things go wrong. So the crucial point is that we absolutely need IL-17 for healthy barrier protection. It's the hero of our story here. On a day-to-day basis, its full-time job is actively defending our mucosal barriers against outside invaders, things like bacteria and fungi. When it spots trouble, it immediately recruits neutrophils. Those are our first responder white blood cells. And it induces antimicrobial peptides to neutralize the threat. Without IL-17 acting as our dedicated defender, well, our borders would be completely overrun by microscopic threats in no time. Now, you might be wondering who actually issues these commands and deploys these cytokines in the first place. Well, the main producer, the commanding officer of this security detail, if you will, is a specific type of cell called the Th17 cell. But brilliantly, Th17 doesn't work alone. It's got an entire highly specialized backup squad. The body actually relies on this super redundant secure network that includes gamma delta T cells, mate cells, ILC3s, neutrophils, and even mast cells. The whole shebang just to ensure this critical cytokine is always ready to go when the borders are threatened. Let's move to and see how this builds, because this security detail operates on a beautifully clean biological chain reaction known as the IL-23/IL-17 axis. It all starts with IL-23 acting as the initial alarm bell. It rings, and that alarm activates the Th17 cells, our commanding officers. And then finally, those Th17 cells produce IL-17, which actually deploys the active defenders to the front lines. So it goes IL-23 to Th17 to IL-17. This elegant three-step molecular pathway is the literal foundation of how our bodies manage barrier-driven inflammation. It really is an incredibly effective security system. But what happens when this protector turns against us? What happens when these border guards don't just stop at neutralizing and invading fungus, but instead they turn their powerful inflammatory weapons inward? Well, this is the exact pivotal moment where the hero of our biological story transforms into a highly destructive rogue force. You see, when the IL-17 axis becomes dysregulated, the results are pretty devastating. We suddenly shift from a calm, protective state to a really aggressive internal attack. We start seeing enthesitis, which is inflammation right where your tendons attach to the bone. We see synovitis in the joint lining, osteitis deep in the bone itself, and even vasculitis inside our blood vessels. It's wild. The very system designed to preserve the integrity of our body actively starts dismantling it, driving massive tissue remodeling and even pathological new bone formation. And guys, this isn't just microscopic theory happening in a petri dish. This dysregulation is the direct engine behind real-world chronic inflammation and suffering for millions of people worldwide. This rogue pathway is the primary driver in a whole spectrum of conditions. We're talking psoriasis, psoriatic arthritis, axial spondyloarthritis, Behçet disease, rheumatoid arthritis, and even inflammatory bowel disease. So we aren't talking about some minor chemical imbalance here. We are talking about the core engine behind some of the most challenging, painful autoimmune conditions in human medicine today. But as we know, immunology is rarely black and white. A really crucial nuance to take away here is that not all Th17 cells are pathogenic. We have to draw a stark contrast. On one hand, we have homeostatic Th17 cells. These are your calm, protective guards maintaining that vital barrier protection we were talking about earlier. But conversely, pathogenic Th17 cells are in that aggressive, dysregulated state, driving chronic inflammation. It's the exact same type of cell, but operating in two entirely different, polarized behaviors. Pretty crazy, right? And this brilliantly illustrates the incredible and, honestly, sometimes really dangerous adaptability of our immune system. It actually gets even more complex with these rogue variants called XTH17 cells. Now, these are cells that started out as normal Th17 cells, but they've actually morphed into highly inflammatory T1-like cells. They're basically biological shapeshifters. This really just proves how dynamic and fluid our cellular biology actually is, and exactly why targeting these specific pathological states without ruining our normal immune defenses is such a delicate balancing act. This sheer complexity is exactly why the IL-17 pathway explains the immunobiology of the SPA, or spondyloarthritis spectrum, way better than the traditional Th1 model ever could. Honestly, this officially cements the death of the old Th1 versus Th2 paradigm. The old model, it simply couldn't account for the unique tissue remodeling and the really specific barrier-driven inflammation we see in these diseases. IL-17 was literally the missing piece of the puzzle that finally unlocked our understanding of these debilitating conditions. But the amazing part is, science didn't just stop at mapping out the problem. Now, what's really interesting about this slide is that by cracking the code of the IL-23/IL-17 axis, researchers ushered in a true therapeutic revolution. We actually found the modern medical solution to this rogue pathway. Enter IL-17 inhibitors. Drugs like secukinumab, izokibep, and bimekizumab are actively transforming patient care right now. They basically act as the ultimate resolution to our biological drama, specifically intercepting those rogue inflammatory triggers without totally shutting down the entire immune system. By directly taming the IL-17 agents, these targeted inhibitors have completely revolutionized the treatment landscape for diseases like psoriasis and spondyloarthritis. They are quite literally giving people their lives back. We've journeyed from just recognizing a simple barrier guard to engineering highly targeted therapies that can literally flip a master switch on autoimmune disease. It's a massive testament to the power of modern immunology. But it definitely leaves us with a thrilling final thought. With the IL-23/IL-17 axis cracked and successfully targeted, what other hidden secrets of the immune system are just waiting to be mapped out and reprogrammed next? Thanks for joining me for this explainer. I'll see you next time.